Alrighty, welcome to this live stream where I'm going to attempt coding on camera, and that makes me nervous. I don't know if this will even be interesting, but the goal today is to enhance Caddy to be able to get certificates for IP addresses from public CAs. Now, currently, Caddy is only, it's kind of hard-coded to only get um, certificates for IP addresses from its own internal issuer or something that's not a public Acme certificate authority, because when this was all implemented, no public certificate authority that supports Acme was issuing IP certificates. But 0SSL apparently does, and so we have a request for Caddy to support getting these kinds of certificates. Let's Encrypt currently does not do IP certificates, so I mean, we can implement this feature, and Caddy might try to get an IP certificate from Let's Encrypt if that's what its like default is, or if that's what it chooses. It will fail, and then it will fall back to 0SSL, or vice versa, and in which if it does 0SSL first, then it will have to use the HTTP challenge, and that's fine. Caddy will support that by default. But I think, yeah, I mean, this isn't going to be a perfect thing. So Caddy will intelligently try and decide whether to use its default Acme certificate issuer to get a certificate, or whether to use its own internal self-signed certificate authority. And we make those decisions based on the type of host name. So if it's localhost or an IP address or something, it won't use. It's a little bigger. It won't use a public certificate authority. In fact, we have some code here. This is in Caddy, and you can see I have a bunch of these function calls for a function in cert magic called subject qualifies for public cert. And so Caddy will kind of make the decision as to whether to get a certificate for or from a public CA or from its own internal issuer based on whether the subject name, the host name, looks like it qualifies for a public certificate or not. And I think we even have a function called subject is IP and subject is internal. So there's a bunch of these functions in cert magic, and currently, so whether subject qualifies for a certificate, these are pretty basic criteria. You cannot get a certificate if the subject if the subject name is empty, obviously. If it starts or ends with a dot, this, especially ending with a dot, is a somewhat controversial decision, but this is in line with what Let's Encrypt has decided to do. And it's also because there's a lot of ambiguity and vagueness in specifications with regards to DNS fully qualified domain names, which since we're not really dealing as a DNS server per se, we don't strictly adhere to that and trailing dot convention. And if it's a wild card, we have some restrictions. You can't get a certificate if the subject is solely a wild card, and if the wild card is not at the beginning of the subject name, and the subject name cannot contain other common special characters. And this is just kind of a sanity check, like, do you have a syntax error in your config or something? These are not valid in host names. Notice that colon and dot and hyphen are not in this list, so those are allowed. Now there's another function here, subject qualifies for public cert, which is a little more specific. So first, the subject has to qualify for a certificate in the first place. And then, so a public cert, by the way, is a certificate from a public certificate authority, such as Let's Encrypt or now ZeroSSL or other public CAs that support Acme. So it has to qualify for a certificate at all. And then this is where we're going to start making changes today. Localhost and .localhost TLD and .local TLD are ineligible. This is still true, but this function subject is internal might have to change a little bit, since we are going to, this next condition, we completely reject IP addresses, and we say, yeah, IP addresses don't get public certificates. And this is something that our documentation also says this is one of the criteria, is Caddy will use its own internal certificate authority for IP addresses. And that works for 99% of the use cases because you typically are using DNS in the public sector, in public networks. So this will have to change because we want to allow this. Now this is tricky because there are some IP addresses that public CAs cannot or will not issue certificates for. And so that includes like the loopback interface, so 127 dot whatever, internal networks like 10 dot or 192 and 168. Those subnets won't be able to get, like, those are pretty obvious, and we'll look at a list of internal ranges and another special IP ranges that public CAs won't issue for. And then of course we have special checks on wildcards for public certificates, which are more strict than getting a certificate at all. So the condition's a little different there for wildcards. We also have a couple other functions, whether subject is an IP address. This is easy. And then whether the subject is internal. Now internal, we just mean something that can't be accessed generally from the public network. So currently, because we haven't, this function isn't called for IP addresses yet. We don't have IPs here, but I mean, this is kind of, it's basically if it's localhost, return true. Because any other subject name could be internal based on your own internal DNS configuration, or it could be public. So we're very careful and conservative here. We know that localhost and .localhost and .local are internal host names because of like RFCs and standards. But that's so this will have to change though when we consider IP addresses, because there are some IP addresses are going to definitely only be internal, and others are going to possibly be public. So this won't be a perfect science. This is not an exact art either. We're gonna go for like 99% of the time being mostly correct. And the idea is that you can override any of Caddy's defaults if they're wrong for your specific case with explicit configuration. Whereas right now, as this issue reported, LED Lamp reports that by hard coding the certificate authority currently, we're actually just still explicitly rejecting it because this does not qualify for a public cert. And this actually is not true anymore because ZeroSSL will generate certificates for IP addresses, but not for reserved IP addresses. And we're going to look at some of these. And so I had forgotten about this, and it's because of this function that I just showed you, subject qualifies for public cert. Because that is an IP address, it doesn't qualify. So we're going to make it so that this is permitted. And so let's look first at, by the way, if my camera in the corner here, so this little frame that you're watching, if this cuts out, it's because my camera has a bad cord, I think, and it will just, or something, and it just kind of will freeze sometimes. So if that happens, I'll try and catch it. By the way, I'm trying to watch the comments. There's some latency in the stream, but go ahead and comment if you have questions and I'll try and notice. I also am doing like screen switching, and so when I switch to my code screen, I have to like go grab the stream page, and that's a little confusing. Anyway, okay, 10 minutes in, let's start coding. So, we look here. I think the first and most obvious change is that we're going to want to get rid of this. So if subject cannot be an IP address, that's not going to be the case anymore. And I've linked here to yeah, so there's a whole there's a bunch of threads on the Let's Encrypt forum as to why they don't do IP certificates, and I can, it's really annoying. There we go. And I can go into that more later, but I think that's an obvious condition we want to remove. So a subject qualifies for a public certificate if it qualifies for a certificate at all, which that is already true because there's nothing here that rejects IP addresses. Subject is not internal. So not subject is internal. This is where we need to do a little be a little careful here because this condition does not apply, but now we need to consider internal IP addresses. So let's add a new condition here, like if the IP, well, if we can parse an IP out of this, then I think, so IP has a few methods on it. Let's see here. So IP is just a byte array. And by the way, there is a new IP type being introduced it might be the standard library. It might be the standard library. I'm not going to look up the issue right now, but Brad Fitzpatrick developed a new IP type that's much more efficient and flexible and like a better representation of IPs all around. And I think that's pretty cool. I think they're working on Tailscale. And so that's going to be probably coming in a future version of Go, but for right now, we're just going to stick with this IP type. Someday we'll probably switch to a different type, but we can see here, there are methods on an IP. Once we've parsed an IP, we can get its default mask, whether an IP is equal, and then we can see whether it's all these types of classes. So it's a global unicast or a local multicast or link local multicast. Really cool. Okay, is loopback. Now we're getting somewhere. So is loopback addresses are clearly internal. Multicast, so I don't actually know a ton about networks and IPs. This function is multicast. I don't know if these are always internal or external, or maybe they're orthogonal to whether the IP is private or public. I think it's orthogonal. It's checking to see if the first element of the byte array, which is can't remember if that's the last octet or the first. Anyway, checking to see if it equals a certain, if it is a certain, let's see, 0xf0. This is embarrassing. I'm really bad. So if it has the same, if it has ones in this position, then or the bits that are 1 have to equal the bits that are 1 here. I clearly have forgotten what defines multicast, and I'm a little rough on my anyway, my bit flipping stuff and IP addresses, but I don't think that's relevant. So loopback is relevant, and then is private. Now this is interesting because obviously we have our function is internal, and so is private might be very helpful here. It returns whether the IP is a private IP addresses. According to this RFC, this is a very old RFC, you can tell because the number is pretty low. And then this RFC, which is for IPv6. And so it's talking about these three ranges, which are reserved as private internets. So this is a good start. If we look at Wikipedia for reserved IP addresses, there's this table of ranges. There are much more than three. However, and then there's IPv6, which we'll also want to consider. So yeah, basically for IPv4, they check these three ranges, and for IPv6, the IANA has assigned this range to unique local unicast. So maybe this is going to be easier for IPv6, but for IPv4, it's just kind of, I don't know how they chose these ranges. That's so weird. Close that. So IPv4, if we look at the IANA Special Purpose Address Registry, there are a bunch of special purpose IPs and ranges. And indeed, these three are private use. And these are the same three that Go considers in this function. So that's nifty, but there are these other ones too, obviously loopback, but there's link local 169.254. And I mean, we should probably consider that too, because I doubt you could get a public CA to issue a certificate for this. Obviously zeros, you're not going to be able to get an IP or a certificate for that, a public certificate anyway. Because I keep saying public because you can do anything you want on your own. No one's going to trust your certificate, but we have a few people watching. Welcome, all three of you. Reserved source destination, these are defined up here. Indicate whether an address from the allocated special purpose address block is valid when used as a source IP, and destination IP. Forwardable, globally reachable. Okay, this might be handy. Globally reachable is a Boolean indicating whether an IP datagram whose destination address is drawn from the allocated special purpose address block is forwardable beyond a specified administrative domain. In other words, the public realm, which that actually is very relevant, I think, to what we're doing. So all these that are false, I guess, cannot be globally, they're not public. Which makes sense, I guess, for most of these. I'm going to copy this list. I'm also going to look at the IPv6 one here, which is, by the way, I have no idea what I'm doing. So some of you tuning in might be networking experts, and feel free to correct me if I'm wrong. I'm probably making mistakes as I make some decisions here, but or file an issue later. Hey, Mohammed, welcome. Mohammed's an awesome maintainer in our community. I really appreciate his support. Okay, so globally reachable. See, there's a bunch here that are false. Unique local, that's what the Go function was mentioning from this RFC. Looks like there's other RFCs that have other ranges that are not globally reachable. Obviously, loopbacks, IPv4 and IPv6 translation addresses. IPv6 is a world of mystery to me, honestly, but I mean, maybe we could just go with this table. Anyway, let me start by saying IP.is private, or because is reserved IP? I don't have a function for this yet, but or is loopback. But this might be covered by, because there are these other ranges that are reserved that aren't covered by is private and is loopback. Let me try. I'm going to use, this is a really poor man's way of extracting. I'm going to extract this data by doing this. And I want to make this into a, I don't know, there's two there. So these are the IPv4s from that table that are not globally reachable. And I want to make this, I feel like, here, let me sort lines. And now I want to remove the redundant, some of these overlap. Like, I believe this is more specific than this one. I can understand why they have different entries in the table, but for our purposes, we, like, I think we want the less specific one. Does that sound right? Anything starting with a 0 dot, I don't think is going to be something you can get a certificate for. So let's remove that and keep most of these. Now there's a bunch of 192.0s you can see. And I think we want the smallest CIDR, whatever this number is called. A little practice here, but I think we want to keep the 2.4. And then this is different. This is also different, so we'll probably keep all those. Okay, and then I think all these are different. And then, wait, isn't this a special one? It's 32, that's, oh yeah, this exact IP address is also not valid. You can't, what is that? That's something special. That's limited broadcast. Yeah. So yeah, /32 means this specific IP only, because 32 is all 32 bits of the IPv4 address are all 4 bytes, because each one of these between the dot is a byte. Math, that's, yeah, cool. So some of these are specific IPs that are, so actually, 92.0, because I'm pretty sure, isn't this included in this? So we could probably get rid of that. And I'm pretty sure that these two are also included in this, because they're in under 192.0. 24, because yeah, this is saying anything with 192 dot, I think. I might be wrong about this, so whatever, this would be a good start. We can fix things later. And I think we want to make this into a slice, right? Whoops. So something like that, and then I'm just gonna, for now, I'm gonna say our reserved ranges. How should I do this? Something like this. And actually, we're gonna need to parse these because we need to treat these as IP addresses, not strings. That's kind of annoying because these are static, these are hard-coded, so maybe an init is good. And reserve IP ranges, something like this, and then we parse this. Oops. Reserved IP ranges. Okay, so I believe we do this in Caddy. How does this work? I think it's cider. Yeah, that's the one. So these are cider ranges that give us. I mean, so if this fails, it's because these are hard-coded. It's because the programmer, me, made a mistake. So let's just panic at startup because that should never happen. IP net. Yeah, there we go. Net.ip is a single IP address. Net.ipnet is a IP network, which I guess is how cider ranges are represented. Okay, I like having inits and stuff at the top because I like to know when I look at a file that if I use this file, it's going to do something to my program. But I also like to have, this is a weird place, I like to have globals, like unexported ones at the bottom. I don't know, that's just kind of that is kind of weird, they're far apart, but it doesn't really matter because you can click to go to definition now, yay. Okay, so let's see how we're doing. Muhammad says you can exclude 192/8, right? Did I cover that already? Sorry, I can't see the chat when I'm in the code window. 192/8. I think we did exclude that. Oh, maybe, wait a second. Is that in the list? 192? I don't see it in the list. So we could. Oh yeah, wait, why is that should be an 8, right? I feel like Muhammad's right, but that's not in the table. I think he's right though. I don't know why you would have a public IP address starting with 192. So let's try that. What could go wrong? Because and actually, how does Go do it? Oh, they do 192. It's so funny how they do this. I mean, it's not super funny. It's really clever, but instead of parsing the cider range like I'm doing, they're doing all the fancy like bit operations. So yeah, they're excluding 192.168. I don't know. This is, yeah, sure, let's try it. Let's try it. Okay, so we have a range. Whoa. That was weird. We have a range of, don't click these, I guess. We have a range of IPs that are internal only, reserved, or at least reserved. So now we need to use these. So let's find where, way down here. Yeah, subject is internal. So now we need to do something with this. So we're parsing if the subject is an IP address, we return if it's a loopback or if it's private. You know, we might not need any of those anymore because if we're going to keep our own list of internal oh yeah, so we need a function is reserved IP bool for range is a, let's see, IPnet range reserved IP ranges. Here, I don't know, I just call it cider even though I know it's just a notation. How does this work? If so, try and remember this. Contains, that's it. So basically we iterate the list, and if we find a range in our list that, here, how about that? That contains the specific IP address, then return true. It's a reserved IP. So I think return is reserved IP. Because our list, in theory, should cover loopback addresses and private addresses, and we'll need to do IPv6 as well. Yeah, because we cover loopback, loop local, the wildcard IP, the yeah, and the private ranges. We already verified that. So now we need to do IPv6. Yay! So we won't be using the go functions is loopback and is private because yeah, because this table, which these tables I imagine are the same. They cite the IANA special purpose registry. So yeah, the go functions only include these three ranges or this one. And there's probably reasons. There's probably a Go issue discussing this, but our use case is more specific. So there's a comment here. A couple comments. Mohammed says it's 192.168.16. And that feels more right. That feels more right. So that's already, yeah, so that's here. But I guess there's just a few IPs within the 192 subnet then that are reserved. So this was a 24, I think. Yeah, it was a 24. So there's another comment. This feels wrong or risky to not just straight up use the list. I'm assuming they mean this list, even if it might have a handful of redundant rules. Yeah, that's probably true. Although, again, I think that there is, like, they probably split some of these out. So, like, again, this and this network and this host on this network. If you have an IP address starting with 0 die and you get a certificate from a public CA, I would love to know. So this is the kind of thing that the reason that I'm removing the duplicates. We can always go back and fix this later though. Let me just get something working. But yeah, you might be very well right that I should probably just take the list at face value. So IPv6, this is going to be a little more fun because IPv6 is complicated. Not applicable 6 to 4. Yeah, let's try this one. So let me do this again. Just get all the tabs here and then delete that. And sort lines ascending. I'm not gonna try and remove duplicates in this one because I don't know IPv6 well enough to do that. I'm even not sure about IPv4 when I do that. So you'll notice that these ranges are much larger because IPv6 has a lot more address space. I'm less familiar with this, but loopback address, unspecified address. I feel like it's a mistake if you get a certificate for any of these. IETF protocol assignments. Oh, this has a footnote. Unless allowed by a more specific allocate. Great. So this is like a maybe. I don't know. Should I remove this one? Maybe I should remove that one. Just for now. Which one is that? 123. And so the thing is, again, if we get this wrong, we can fix the code later. Go ahead and submit a pull request, cite your source. I'd love to know why, like the justification for making the change. And or you can always override Caddy's automated decision as to whether to use a public CA or not in your config. So I feel like so there's a comment here. I feel like anything that might be allocated in any way might not be usable for public cert. Also probably true. I think CAs are, I think that's why Let's Encrypt doesn't issue IP certificates. They're very conservative about kind of what assertion that's making in IP space, and given the complexities here, they're being conservative. So yeah, let's start with this. Make this into a slice. Oh, yeah. There we go. Separated by a new line. That kind of makes sense, right? So this should cover loopbacks, yes, and link local. Okay, good. Yeah, so, and this covers the one case that the Go standard library also covers. Okay, so there's our reserved IP spaces, I think. And we are now using this in our function is reserved IP. And we don't need the Go standard library functions there because our use case, again, is a little more narrow. The Go standard libraries tries to be like very conservative in permitting all the possible use cases and being like playing well with them. And so their choices are very safe. Ours are, again, more specific because it's like, what would a public CA issue certificates for? And the thing is, this can change. This is not something, I don't think that's a big deal, especially as CA policies continue to change and all that. So now I think we handle IP. I think this function answers the question as to whether an IP is internal or private or whatever better, because before it didn't consider IPs at all. So probably should write tests for this. Yes, I'm not going to do that right now. Yes, I probably should write tests. But right now we're live streaming the new feature, so I'm not going to take all your time and write a test. Maybe in a different stream. This is an easy thing to test. It's super easy. Okay, so subject is internal. So this comment is still true. Localhost, as well as some reserved IP ranges. I say some because some reserved IP ranges are public. Yeah. Only one wildcard. Okay, so think that's the only... Checking some notes here. I think that's all that needs to happen, I think. Subject is internal. Subject is IP. Is reserved IP. I'm gonna move this. I don't like having unexported functions right in between like two exported ones. Other people probably like the unexported function to be close to where it's called. Totally get that. I just think that this, I don't know, this is fine. So some comments suggesting that they would rather block everything listed in both tables, and only if someone complains about needing one of them, then we can loosen them, loosen the restrictions. That's, yeah, that's also a very valid approach. The other thing too is that we're not the certificate authority, so the certificate authority would probably want to be more conservative here. I don't think Caddy has to be quite as careful in that sense, because ultimately it's the CA's decision to whether to issue a certificate. And they can block other IP addresses. They might even only have an allow list of certain IP addresses. We're just trying to make a best guess here. And you can always override things in config yourself later. And if this turns out to be a big mistake and we're not, you know, the approach isn't right or something, we can adjust that later. There's another comment. There's an IPv6 thing where you have half IPv6 and an IPv4 appended to the end. Yeah, I remember that. So, I don't know, is that covered in this table? Is that like related to this? Or this? I've seen that before though. I'm trying to remember. I have no idea how that gets handled. So, look at this. There's an IPv6 range for documentation and example source code. So kind of like example.com, but like this whole IP range can be used as just like a bogus address. That's kind of cool. It's a huge space. I cannot believe how big IPv6 is. Yeah, anyway, that's kind of interesting. So now calling, I wonder if we broke any tests. Nope. We don't have a great test coverage, I guess. Let's fix that in a later stream. But anyway, I think that's all that's going to be needed. I'm going to go ahead and test this, try this out. I'll probably write tests in a different stream if you would be interested in that, but now subject qualifies for public cert. Oh, we probably should update this comment really quick. So this is the go.comment. Returns true if the subject name appears eligible for automagic TLS or the public CA, such as Let's Encrypt. For example, localhost and IP addresses are not eligible. Internal IP addresses are not eligible. By the way, if someone writes a VS Code or maybe a Go Please feature or something where as you write a comment, it automatically basically I want my comments to have line wrapping, word wrapping when I change them, because I like comments, especially go.comments, to kind of be the same width, maybe a little wider than the code underneath it, especially the function signature. So, and then I kind of, as I change it, I just want it to automatically wrap for me. So I don't have to, like, if I make a change on line 1 and then I have to go and change the wrapping on all the other lines so that the comment looks good and readable and isn't, you don't have one line that's like super long. If anyone would implement that, I will thank you a lot, and if you accept donations, I will probably donate for that, because this is like my #1 pain point about updating docs is getting the comment to still look presentable and readable and not ridiculous. Internal IP address, I guess they're gonna have to public CA. Yeah, okay, so I think we just need to add internal IPs. Subject is an internal facing hostname or address. Subject is IP. I wonder if we're going to use, we probably use this in Caddy. Do we use this in Caddy still? Oh yeah, okay. We actually have our own, we do call this. So we have, in Caddy now, we have our own function called subject qualifies for public cert. And the reason is, it's basically the same as the one we were just working with in CertMagic, except this allows domains with multiple wildcard levels like star.example.com. And the reason for this is, so this function is more lenient. And the reason that we need this is because, it's because we are trying to match automation policies. This is called a couple of places. One in the Caddy file. And there's this whole comment explaining why. I may not qualify. Oh yeah, because if you have an automation policy in your Caddy, in your JSON config that has a name like star.star.tld, you can't get a certificate for that except when you have on-demand enabled. The automation policy, the name is not actually being used to manage certificates, it's only being used to match the automation policy. So you might want to match on these domains, even though you're not getting a certificate with 2 wildcards, obviously, because on-demand doesn't do that. I think this logic could be generalized better. But anyway, the point is that we need our custom implementation here. So it's basically, it should be the same thing. Subject qualifies for public cert. Let's actually make sure that we're still in sync here. So qualifies for cert, which we are skipping that check again because of the wildcard. Subject is not internal, so that's preserved. Subject is IP. I think we can remove this actually now because we are allowing certificates for IP addresses. And then we have that special condition for on-demand, which doesn't do wildcard certificates. Yeah, I think that's right. I'm gonna have to test this now. But anyway, thank you for joining today, and hope that was interesting. We'll try and commit and push this here in a little bit. Forgot to reopen the issue. It's in the Caddy repo. It probably should be in the CertMagic repo, and I guess I could move it. Maybe I'll do that. Transfer. Yeah, because the fix is in CertMagic mostly, but yeah, so thanks for joining me today. If this was interesting, let me know, and I'll be happy to do this again. And also, if you find Caddy useful or CertMagic useful, I would be happy to accept your sponsorship and to continue doing these streams and developing Caddy and also engaging with you as the community. So you can see the sponsorship link there at the bottom of the video, github.com/sponsors/mholt. And because sponsors are how I'm able to work on Caddy as much as I do. So we definitely are relying on that. So thank you very much.